Welcome to this video on circle theorems. Here I'll be showing you the theorems of circles and we will solve examples to explain the theorems. So watch this video to the end and see how some questions are handled using the circle theorems. So on my book I have 8 theorems, so we'll see them one after the other. Now the first one. The angle subtended by an arc at the center of the circle is twice the angle subtended by that same arc at any other point on the circumference. Now this is what we are saying. This is an arc. This arc, let's say arc AB. This arc subtends this angle at the center. Now the rule says that the angle that this arc AB subtends at the center is 2 times any other angle that this same arc AB subtends at any other point on the circumference. Now, this arc AB also subtends an angle here. So the rule says that if this angle here is theta, then this one here will be 2 theta. That's what the rule says. Now, look at this. This angle here is also an angle at the center. Remember, we considered this one for the first case. So I want to consider this one now. Now, it is this arc AB that goes this way that subtends this angle at the center. So it is this same arc AB that subtends this one here. That's this one you can see here. So the rule says that if here is theta, this one here is 2 theta. This is it for the first one. Now let's see the second theorem. So the second one we are going to consider is the angles in the same segment theorem. The rule says that angles subtended in the same segment are equal. So you can see that all of these angles here and this, all of them are in the same segment. So if here is theta, definitely all others will also be what? Theta, since angles in the same segment are equal. Alright, the third on my list is the angle in a semicircle theorem. The angle subtended by a semicircle or angle subtended in a semicircle is right angles, that's 90 degrees. This is the center of the circle. So a line that is drawn through the center that touches 2 points on the circumference is the diameter. That is, it cuts the circle into 2 equal halves. So the angle subtended by this semicircle formed here is 90 degrees. The fourth one is on cyclic quadrilaterals. And the rule says that opposite angles of a cyclic quadrilaterals are supplementary. And supplementary angles are angles that add up to 180. So this is a quadrilateral, that is a polygon with 4 sides, is what a quadrilateral is. Any shape that has 4 sides is a quadrilateral. So I can see a shape with 4 sides inscribed inside a circle. So an angle can be formed here, let's say X. Another one can be formed here, let's say Y. Let's neglect these 2 first. Let's use these 2 to explain. Now, the rule says that for these 2 angles that are opposite each other inside these cyclic quadrilaterals, their sum is equal to 180. That is, X plus Y is equal to what? 180 degrees. This is the fifth one. The exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. Alright. Now, look at this cyclic quadrilateral. You can see it very well. Now, an angle can be formed here. As well, an angle can be formed here. This interior angle here is equal to this opposite exterior angle. So, if here is X, here is also what? X. That's the principle of exterior angle equal to opposite interior angle. This is rule 6 or theorem 6. It says that the angle that lies between a tangent and a chord is equal to the angle subtended by the same chord in the alternate segment. Now, this is what we are saying. You can see this line that touches the circle at this point. This line is called a tangent. This line is called a chord. Okay? So, the rule says that the angle formed between this chord and this tangent is equal to the angle that is subtended by the same chord in the alternate segment. This chord subtends an angle at this point here. Alright, so the rule says that this angle here that is formed between this chord and this tangent is equal to the angle formed by this chord in the alternate segment. So if here is x, here is also what? X. The angle between a tangent and a radius is 90 degrees. That's the first one. The general rule is the tangent to a circle rule. So the first one says the angle between a tangent and the radius is 90 degrees. Alright, look at this circle very well. This is the center of the circle. Okay, so a line that is drawn from the center to any other point on the circumference is called a radius. Alright, and the rule says that the angle formed between the radius and the tangent is 90 degrees. That's the first one. I can also form another line here. So this same line drawn from the center to the circumference is also called a radius. The second rule says that tangents which meet at the same point are equal in length. What the second theorem is saying that these two tangents which meet at this point are equal. Okay, so let's start with this very question. Question 1. In the diagram beside, this is the diagram. O is the center of the circle. It is the center with O. If angle QOR is 290, we are asked to find the size of angle QPR. QPR. That's this very angle that is here. That's the size we are asked to find. Okay, now we may not need to go back to the rules and see which of them will be used to solve the question. But from the first rule that I gave, I told you that the angle that is formed here at this point is 2 times what is here. So if I know what is here at this point, I can get what is here. Now, they said that the angle at this exterior is 290 degrees. But I need what is here. And I know that sum of angles at a point is 360 degrees. So if I can subtract 290 from 360, I have gotten what is inside. Now, what is 360 minus 290? 360 minus 290 is 70 degrees. So here is 70 degrees. I can now connect this and this. So whatever is here is half of what is here. If I multiply this by 2, I'll get this. If I divide this by 2, I'll get this. So to get the angle that is formed here, which is angle QPR, I'll divide 70 by 2. So 70 divided by 2 is 35 degrees. The angle formed here is 35 degrees. And I can see this in option C. You can see that I didn't even do any solving. I just looked at it because I understood the principle. Then I got my answer within seconds. This is the beauty of circle theory. Question 2 says, in the diagram below, ATR is a tangent at the point T. If angle TOB, that's this angle here, is 145 degrees, like you can see, we have to find angle TAO, which is this angle that is here. Alright, before I will solve, I know that the angle formed between this radius and this tangent is 90 degrees. From the theorem which states that the angle between the tangent and the radius is what? 90. So here is already 90. We are looking for this angle here. Now, what would this 145 help us to do? But the sum of angles in a straight line is equal to 180. So if here is 145 and everything here is 180, it means that the one that is here only is 180 minus 145, which is 35 degrees. So here is 35 degrees. All right, can you see that this is a triangle? Triangle ATO. ATO, that's this one you can see here. I have two angles. I'm looking for one. So I can use the principle of the sum of angles in the triangle to calculate for this. Let's call this X, which is angle TAO. Okay, so by the principle of triangles, X plus 35, which is this one, plus 90 degrees is equal to what? 180 degrees. The reason is because of sum of angles in a what? Triangle. Alright. 35 plus 90 is 125. X plus 125 is equal to 180 degrees. So if I collect like terms, it means that X is equal to 180 minus 125, and that's equal to 55 degrees. Now take note, when solving circle theorem problems, the theorems to be applied may not just be the circle theorems alone. We may require other theorems of geometry to solve. Like here now, we use the angles in the triangle theorem. Here, we said that sum of angles in a straight line is 180. That one is not a circle theorem. In our question 1, here, we said that sum of angles at a point is equal to 360. So we must be familiar with so many geometry theorems to be able to solve some questions in circle theorems. That's the point. So let's go to question 3. Alright, this is question 3. It says, in the diagram below, O is the center of the circle and angle POR is 126 degrees. O is the center. Angle POR, this angle at this point, is 126 degrees. 126. We have to find angle PQR, which is this angle inside. Now, under circle geometry, this 126 has no direct connection with this angle formed here. But based on what I told you in theorem 1, it is this angle that is outside that has a direct connection with what is here. Okay? So, but I know that everything here at this center is 360 degrees angles at a point. So if I subtract 126 from 360, I will get what is outside. And 360 minus 126 is 234 degrees. So the angle here is 234 degrees. Now, how do I get what is here? Remember, the angle subtended by an arc at the center is 2 times the angle subtended by that same arc at any other point on the circumference. So to get this value of angle PQR, I will divide what is here by 2. And if I do that, I will get 117 degrees. So here is 117 degrees. It's simple. Question 4, it says, in the diagram below, this is the diagram, PQR is a tangent to the circle QST at Q. PQR is a tangent to this circle. Good. Now, if line QT is equal to line ST, this is line QT, this is line ST. So QT, which is this line, is equal to line ST, which is this line. That's why you can see a marking to show that the two lines are equal based on what the question says. And angle SQR is 68 degrees. Okay, SQR, 68 degrees. We have to find angle PQT. PQT. Oh, that's the angle at this point. Now, this angle that is outside, angle SQR, is 68 degrees. It is equal to what is here. going by the principle of angles in alternate segments, you can see that rule says that the angle between a chord, this is a chord, QS, and the tangent, PR, is equal to the angle that the chord subtend in the alternate segment. So this chord subtends this angle at this alternate segment. So the angle between the chord and the tangent, which is 68, is equal to the one that is subtended at this point in the alternate segment. So since here is 68 degrees, here will also be what? 68 degrees. Good. Let me turn it upside down so we can see it very well. Now, they said these two lines are equal. That means this triangle here is an isosceles triangle, because it is an isosceles triangle that has two sides equal, and the base angles are also equal. So here, if I call this one P, here is also what? P. Alright? So by isosceles triangle theorem, two sides are equal and the base angles are also what? Equal. Now check something very well before I proceed to get the value of P. Check this. If this angle is P, can you see that it is equal to this angle here, angle PQT, because this angle here is equal to the angle in the alternate segment. You can see that, very interesting to see. So whatever I get as P here is what this angle is equal to. So what we'll do now is to get the value of P first, so that that angle will now be equal to what is outside, PQT. So this is a triangle. The sum of angles in a triangle is 180. That means 68 plus P plus the other P, 68 plus P is equal to what? 180 degrees. Alright. P plus P is 2P. 68 plus 2P is equal to 180 degrees. So collecting like terms, 2P is equal to 180 minus 68. So that 2P is equal to 112 degrees. So to get the value of P, divide both sides by 2. 2 cancel 2. So therefore P is equal to 112 all over 2, and that is 56 degrees. 56 degrees. So the value of P here is 56 degrees. Therefore, the angle in the alternate segment, which is this P now, is equal to the one that is here, formed between this chord and this tangent. So here is also what? 56 degrees. I hope you understand this very well. So 56 degrees is in our option C. Alright, this is question 5. In the diagram beside, this is the diagram, angle SPQ is 79 degrees. SPQ, 79 degrees. We have to find angle SRQ. SRQ, this angle here is what we have to find. Which of those circle theorem will help me solve for this angle SRQ? I know that this is a cyclic quadrilateral, and opposite angles, they are facing each other, are supplementary. If I call this angle X, it means that 79 plus X will add up to 180. So 79 plus X is equal to what? 180 degrees. What's the reason? Opposite angles of a cyclic quadrilateral. So our X will be equal to 180 degrees minus 79, and that is 101 degrees. And that I can see in my option E. Now this is my question 6. Okay, question 6 is, in the diagram below, this is the diagram, PQ arrow is a circle with center O. PQ arrow is a circle with center O. This is the center. Angle QPR is 50 degrees. QPRO, this angle here, 50 degrees. Angle PQO, 30 degrees. PQO, this one, 30 degrees. And angle ORP, this angle ORP equal to M, is M. We have to find this value of M. I can see a triangle that is formed here, okay? So the radius and the radius are the same. And if the radius are the same, it means that the triangle is an isosceles triangle. That is, two sides are equal and the base angles are also what? Equal. Just watch this very carefully, please. Now, this 50 degrees, can I connect it with what is here? Yes. This is the angle at center. And angle at center rule says that the angle at center is 2 times the angle at any other point on the circumference. So if here is 50 degrees, then here is 2 times 50, which is 100. Can we get the value of P? You will see why I'm solving for P. You will see. Let's get the value of P. Since it is a triangle, then 100 plus P is equal to 180 degrees. Because it is angles in a what? Triangle. So 100 plus 2P is equal to 180 degrees. Then 2P is equal to 180 degrees minus 100 degrees, and that will give us 80 degrees. So to get the value of P, divide both sides by 2. 2 cancel 2. It means that P is equal to 40 degrees. So P here is 40, P here is also 40. Now check this out. We have gotten the values for P, but you can see that this is a triangle itself, triangle PQRO, everything here. So the sum of angles in the triangle will sum up to 180. The angles of the triangle, it will now be 50 degrees, 30 plus P degrees, then M plus P. I just hope you are understanding what I'm doing. I just replicated this triangle now. I drew it out. So the one here is 50. Everything here is what I will put here. And everything here is what I will put here. So here is 30 plus P. But we said P is 40. It means that this is 30 plus 40. So here is 70. Here is 40, which is P. So here is now M plus 40. So here I will write M plus 40 in degrees. So this is now a triangle. I will now solve for the value of M using sum of angles in a triangle rule. 50 plus 70 plus M plus 40 will sum up to what? 180. The reason is because of sum of angles in a triangle. Okay? 50 plus 70 is 120. 120 plus 40 is 160. So 160 plus M equal to what? 180. Alright. M will simply be equal to 180 minus 160 degrees, which is equal to what? 20 degrees. So M is 20 degrees. And that we can see as option A. This is question 7. Question 7 says, in the figure, this is the figure, PS equal to S arrow. PS is equal to S arrow. Thus, these two lines are equal. And arrow S is a tangent to the circle at arrow. Arrow S is a tangent to the circle at arrow. That means this tangent, it touches the circle at this point, arrow. Okay, angle QRX is equal to 72 degrees. QRX, 72 degrees. We have to find angle SPR. SPR. That's this angle that is here. Okay, from what we have studied so far, the angle here is actually 72 degrees. How is it 72? You can see angles in alternate segments. Yes, these two angles are the same. By now, you know what angles in alternate segments are. So, you can see this is a triangle, SPR, and the two sides of this triangle are equal. So, the triangle is an isosceles triangle. Now, for an isosceles triangle, the base angles are equal. So, whatever this angle is, that's what this angle is also. Now, if here is S, we call this angle S, then this one is also what? X. How do we now get this one that is here to complete the angles in the triangle? Now, I can see that this is a straight line, PQ. And angles in a straight line is how many? 180. So if part of it is already 72, to get the other one, I will just remove 72 from 180. It will give me what is left. 180 minus 72 is 108 degrees. So here is 108 degrees. So my triangle is complete. Remember, we're looking for this angle here, which is X. So we will use the sum of angles in the triangle rule to solve for X. So 108 plus X, all of them sum up to 180 degrees. Reason is because angles in a triangle. Alright, X plus X is 2X. Then this is 108 plus 2X equal to 180. So that 2X is equal to 180 minus 108. Good. And 2X is equal to what? 72 degrees. To get X, divide both sides by 2. 2 cancel 2. Therefore, X is equal to 36 degrees. 72 divided by 2 is 36. And that we can see as option B. So, it means that angle SPR, this angle here is 36 degrees. Question 8, which reads, in the figure below, PQRS is a circle. If PQT and SRT, PQT, SRT are straight lines, find the value of X. Now I can see 81, which is interior. It is opposite this one outside. That is to say, this angle here is what? 81. We studied the geometry theorem. Alright, if this angle is 81 and this is a triangle, this is a triangle. Can I get this angle? Yes, I can get it. Everything here is sum of angles in a straight line. Part of it is already X. It means that the remaining part is 180 minus X, since sum of angles in a straight line is 180. So this one is 180 minus X. Good. So my triangle is complete. I can now solve for X using sum of angles in a triangle. Alright. 180 minus X plus 81. I want to add up all the angles. Plus 22 degrees. We sum up to 180 degrees. Alright. In fact, 180 cancel 180. Yes. So, minus X plus 81 plus 22 is 103 degrees, which is equal to what? 0. Nothing is left here. We cancel this and this, so 0 is left. To get the value of X, just say, okay, minus X is equal to 103 will cross and turn to minus 103 degrees. The 0 here has no significance. Minus cancel minus. What's X? X is now what? 103 degrees. It's as simple as this. And this we can see, option C. So this is basically about circle geometry. Basically about circle theorems. I hope you enjoyed this video. I hope you like it. Keep supporting by subscribing to this channel. Share this video to your friends. Like and comment. Remember to subscribe and turn on notifications to get updated whenever new content come up in this channel. I'll see you in the next video. Till I see you again, take good care of yourself.